Hello students, welcome to another system programming class. In the previous class we have discussed about macros and then we also saw about macros with arguments. Hope you remember. If you can remember the slide which we have seen, so this is how you write a macro. For example, I'm just giving a recap of what we saw in the last class. Here INCR is going to be a macro. Macro is nothing but like a function. It has arguments, argument 1, 2 and 3. Right? And the function is written from the next line. So there are 3 lines of coding. So all this comprises of a function. So the function should end with end. Macro end is the meaning of it. It has to end with macro end. A function or a macro should begin with the keyword macro. MACRO should be a keyword which the macro has to begin with, and the macro has to end with this keyword end. Right? So this is how a macro with arguments will be. So the arguments will be passed. So for example, this is like a function definition and below that is nothing but like a function call. Right? So this is what we saw. Then we also saw that there are 2 types of ways of giving arguments. One is positional argument, the other one is the keyword argument. Today we are going to discuss about the conditional macros. So how can we define macros which are conditional macros? So what do you mean by a condition? So we have studied if command. Yes. So if condition, then statement. It is very, very similar to an if condition. So we have studied if condition in C, C++ and Java. So here conditional macro is in a macro. How can you use a conditional macro or how can you use a if command? Okay, based on a condition, how can you take decisions inside a macro is what we are going to see. As I told you again, I remind you, macro is like a function. Inside a function, how can you write a conditional statement is what we are going to see today. Okay. Here in this assembly level language IBM 360, we have 2 pseudo ops. Remember, they are not machine ops, they are only pseudo ops. Pseudo ops are nothing but the instruction given to the assembler. Okay, these are just the instructions given to the assembler. So you have 2 pseudo ops. So one is AIF, which is nothing but similar to your if command. So this particular pseudo op AIF, you can take it as an assembly level language if command, AIF. So this conditional statement is used to have a conditional flow of your control, which means based on the condition only your flow of control will happen. Right? So there is another unconditional statement also available here. That is nothing but go. It's like a go to. We have seen go to command in basic. Similar to that, this is a go command. This is unconditional. Right? Like you saw jump command in microprocessor. So you also had conditional jump and unconditional jump similarly. This is unconditional statement AGO. Here means just go to a particular line. Your cursor will be transferred to that particular line. So these are the 2 commands. Right? So again I repeat. AIF is a conditional pseudo op and AGO is an unconditional pseudo op. So how do you actually branch? How the branching happens here? So branching in AIF happens based on a condition. AIF, if a certain condition is true, then you transfer your control to a label. In our case, it is going to be transferred to a label. We don't have line numbers, instead we have labels. Similarly, AGO, what happens? Without checking any condition, as soon as it encounters this keyword AGO, it looks at the label and just transfers the control to that particular label. So this is unconditional. Right? So both are going to use labels to transfer the control. So let us see one example here. Right. So it is going to be a similar program whatever we have seen so far. First let me explain what your program is all about and then we will see how it is going to work. Though it looks like a big program, it is very, very simple. Okay, so now only look at the source code side, don't look at the expanded program side. So just go through, let's only concentrate on the source program side. Okay, let me break it up for you. First thing is there is a macro written. So we are using a keyword macro and we are going to use a keyword macro end. Yes, this you already know, right? So there is no confusion there. You are going to have a macro definition. You have the keyword macro and you are going to have a keyword macro end. Next line is the definition of the macro. The name of the macro is INCR and this macro is going to have arguments such as count, argument 1, argument 2, argument 3 and so on. Right? It has count 1, 2 and 3. The first line here says A. A here means add command. Add the contents of the argument 1 with the contents of register 1 and store the resultant register 1 itself is the meaning of it. So add command, what it does, it adds the contents of the argument 1 to the contents of register 1 and stores the sum in register 1 itself. Right? Similarly, let me skip this if condition and go to the next line. Here again there is another add instruction. What it does, it adds the contents of argument 2 to the contents of register 2 and stores the sum in register 2 itself. Again another add statement is there wherein the value of argument 3 is going to be added to the contents of register 3 and the result is going to be stored in register 3 itself. This is what is happening. Right? So this is what is happening in our program. Here the program written in such a way that all the 3 lines, I don't want all the 3 lines to be executed all at once. So far whatever we have seen, we had 3 instructions, all 3 will be executed all at once. Okay. In this particular program, this scenario is in such a way that we don't want everything to be executed all the time. So how should it be executed? It should depend on the value of count. Say for example, if this value count, so can you see the definition has one argument count? If the value of count is passed as 1, then the first line only will be executed. Right? If the value of count is passed to be 2, then the first and the second line has to be executed. If the count value is going to be 3, then all the 3 lines should be executed. That's the thing. How do we write it? This is the problem for you. Only you want first line to be executed when count is 1, first and second line to be executed when count is 2. All the 3 lines has to be executed when count is 3. This is your problem. Let us see how we are going to do it. Say, this is the program AIF. If count is equal to 1. Okay. If count is equal to 1, then go to final label. Where is the final label? The final label is here in the last line, which means you are ending the program. Right? AIF. Okay, it means a if command. That's it. You can read it as if. If count is equal to 1, then transfer the control to this label final. So that label name can be anything. So here I am using a label name called final. In your textbook it is FIN. Okay. So it means that there is a label, you have to transfer your control there. So what it means, if the count is 1, which means it would have already executed the first line. Yes, after that it doesn't want to execute any other line, so it has to go to final. Okay. Same way, if the count value is 2, so what happens? Now, if count is 1, no, actually the count is going to be 2 now. Let me take the second case, count value is 2 now. So I'm going to here come to this statement. So let us start. So I'm going to come add argument 1's value, I'm going to add it with register 1, store it there in register 1 only. Then I'm going to check if count value is equal to 1. No, now the count value is equal to 2. Okay, so you will not go to final, instead you will come to the next line. Right? If the condition is false, you will come to the next line. So that is how if command works. Right, in the next line what is there? Argument 2 has to be added with register 2 and the result has to be stored in register 2. So it will do that addition. Right, that also will happen. Then again we will go to this line. If count is equal to 2, yes, now our count is equal to 2. So you go to final, which means you skip this line. You are going to skip this line when count is equal to 2. You understand? If count is equal to 3, what happens? Count is equal to 3, it will execute the first line. It will check if it is equal to 1, no. So it will come to the next line. It will do the second instruction also, it will, addition also happens, this line also is executed. Then it comes to this if condition, count is equal to 3, if count is equal to 3, no, it is, I'm sorry, count is equal to 2, no, it is equal to 3. So what happens, it goes to the next line only, execute this line and then only go to the last line. Which means when count is equal to 3, it will add the argument 1 with register 1, add the argument 2 with register 2, it will add the argument 3 also with register 3. All the 3 will happen. Only then you will come to end. So this is the logic of this particular program. You understand? Yes. So let us say, give an example and test. Whatever I told you now in words, we are going to see it in an example format. See here, INCR 3, data 1, data 2, data 3 are there. What do you mean by 3 here? 3 is the first parameter, which is nothing but your count. Okay. If count is equal to 3, I will do how many additions? 3 additions I will do. What are the ones? So here you can see, I will add data 1 with register 1. I will add data 2 with register 2. I will add data 3 with register 3. All the 3 will happen when the count value is equal to 3. Right? If it is 2, what happens? Only data 2 and data 3 are here. So what happens? Data 3 will have to add with register 1, data 2 will have to add with register 2, and that's it. You have to end the loop because it will be count will be equal to 2, end the loop here and skip this line and come to this final line, right? What if the count value is 1? Okay, it will execute this first line. Here you have it. It will execute the first line, right? Then it will check if count is equal to 1. If it is yes, then it will go to final, which means it will come here, which means it will skip all these lines. It will not execute any of this line if count is equal to 1. You understand? So at situations whenever we need something like this, we have defined a function or a macro, but we don't want the macro to execute the same way all the times. So we wanted to have some conditions and we wanted to execute only based on conditions. Something like this. This is one of the examples where sometimes we want only one line of code to be executed, sometimes we want 2 lines of code to be executed, sometimes we want all the 3 lines of code to be executed. So this situation we will go in for what macro is this? This is a conditional macro. Yes, condition also, this is AIF is conditional, right? AGO is just say go, that is unconditional. So the same example, you can also have one line of code where you say if count is equal to 1, go to some line. Okay, so that's all, that condition also you can have, right? So this is nothing but a conditional pseudo op in a macro. Hope you understand. Right. So when you say this program in the beginning, maybe there were you felt it was difficult, but I think now you should have understood it by now. Okay. If you have any doubts in what the data is all about, we have already discussed. I will want to tell you again so that you are not confused. I don't want you to leave the slide confused. Okay. So we already know that how to declare a variable. Yes, here you call them a symbol. So there are 3 symbols if you note down, data 1, data 2 and data 3. So define constant means what happens, you also define, say that this is how much of memory they will need and what is the value stored. You understand? Define storage only defines a storage space. Okay, here it defines the storage space plus also says what value has to be stored. Right, that is the use of this DC command. Okay, just that you know. Okay, so how have we seen this program? The source code actually will look like this. Whatever you see in your left hand side, that is how your source code is going to look like when you have conditional macros. Okay, this is how a user should write a program. What do you mean by expanded program is, after your microprocessor has taken the source code as input, and what will be the output is will be your expanded program will be the output of your microprocessor. The input you have to provide to the microprocessor is your source program with macros, which is not expanded. You will only have a macro definition and you will only have a macro call. This is called as a macro call. This part is called as a macro definition. So this is what you will write in a program. It is the work of the microprocessor to expand it, right? So that there won't be any overhead in transferring the control to various locations. Okay, so you just have to expand the given macros, right? Yes. So let us move on to the next topic. The next topic for today is nothing but, it's like a nested macro or macro calls within a macro. It is like your nested functions, function inside a function, something like that, right? It is called macro calls inside a macro. So let us see one example so that you understand what I mean by macro calls inside a macro. Right. Just look at this example. So we have defined a macro. Yes, so far what we have seen is, we have seen the macro keyword and we have seen and keyword. In between we have seen some kind of instructions. Some instructions were there. But here there is a macro definition, starts with the keyword macro. There is some command add1. Okay, the add1 is not there. This is not a command of IBM 360 at all. Okay, then what is add1? add1 is another macro. Okay, so add1 here is nothing but it is another macro. So you have to understand what do you mean by a macro and how that macro is again called inside another macro. That is what we are going to see. Okay, yes, here see. Let's go to this example, particular example. A macro is written here. Okay, there is a macro written here. That macro is nothing but known as add1. Yes, it's a macro written, it is nothing but add1. But when you see this particular macro, what happens here? Macro keyword is there, M, that's what I was telling you now. Macro keyword is there, M and is there, but we don't understand what is this ADDS is. I understand that maybe this is the name of the macro, yeah, It follows the syntax as the name of a macro, but we don't know what is ADD1. Yes, there is no command in IBM 360 which has the name ADD1. What it could be? It is nothing but it is another macro, right? So see here, this another macro is defined here. ADD1 is a macro which is defined here, right? Okay, this another macro which is called ADD1 is defined here. It only has commands, there is instructions, there is no macro inside it. So the name of the macro is ADD1. So what happens, does your microprocessor does, whenever it encounters ADD1, it will change that particular statement into L1 comma argument, A1 comma is equal to F1, ST1 comma argument. That's how it will replace. It will replace all ADD1 into these 3 lines of coding. So that's what is called as macro expansion. We know that. Okay. We don't have any doubt with the first macro written there. So we know, we have seen it. Same examples, we have seen similar programs. Right. So what is more important here is you have to take a closer look at the second macro definition here. Second macro definition also starts with a macro keyword. It ends with the MN keyword. The name of the macro here is ADDS. It has 3 arguments. Till that there is no doubt. Okay. Instead of having 3 instructions, it has ADD1, which means ADD1 we just now saw that was another macro. So there is 3 macro calls here. Okay. So just note down carefully. These 3 are macro calls. So where is this macro calls is happening? These macro calls are not happening in the main program. It is happening inside another macro. This particular scenario is called as macro calls within a macro. Macro calls within a macro, right? So if you see an example and see how the expanded code looks like, then you will have a clarity. Okay, that will be in the next slide. So before going to that slide, let me again try to explain the same set of concepts here. The concept here is, first there is a macro definition. The name of the macro definition is ADD1. Right? So it starts with a macro, it ends with macro over. We have defined a macro that is called macro definition. Similarly, I want to define another macro. Yeah, can I have more than one function? Yes, I can have. So I'm going to define in the next line itself. I'm defining another macro. Okay, the name of the macro is ADDS. So I'm expecting to have some instructions, but instead there is a macro call. So I'm calling another macro. You understand? So what happens if this is a scenario? How is this handled? So what is the meaning of it? How do you break it up? Let us see. Yeah, same example here, right? So there was a macro ADD1. Yes, defined. Okay. I am not calling ADD1 anywhere in my program. ADD1 I will not call anywhere in the main program. But what has happened here? I have defined another macro called ADDS. Inside that I am calling. Inside that macro I am calling another macro. Is it allowed? Yes, of course it is allowed. Right? So how is it, what happens, how does it execute? This is what we have to discuss. So there is a macro called ADDS. Inside that there is 3 times they are calling macro ADD1. 3 times they are calling this macro ADD1. So that is what happens. So how are we going to deal with it? Right. Here in my main program I am not calling ADD1. I am not using that at all. But what I am calling ADDS only. So though I call ADDS, somehow ADD1 also will get called because that is inside your ADDS macro. So let us see. ADDS macro, wherever your microprocessor finds it, it will expand it into 3 lines, 3 commands. What are those 3 commands? ADD1 argument 1, ADD1 argument 2 and ADD1 argument 3. So that expansion has happened here. No doubt in that. Okay, it has happened here. That's how it has to be expanded. But will the microprocessor stop with this? No, because it has to again expand the another macro which is present here. That is nothing but ADD1. Okay, so that has to be expanded. So let us guess before going and seeing what comes in the slide. Let me make you guess. So what happens? What will ADD1 be replaced with? ADD1 has to be replaced with some instructions which are nothing but L1 comma argument, A1 comma literal, ST1 comma argument. So these 3 lines has to be replaced where? With ADD1. So ADD1 has to be removed and these 3 lines has to come. So let us see what happens. See. For ADD1 data 1, so it is L1 comma data 1 is the argument. In the second time data 2 is the argument. Third time data 3 is the argument. So how will your program actually be loaded into your main memory? After your microprocessor has expanded the program like this, the actual program which had two macros will not be loaded. This program will not be loaded in the main memory for execution. Instead, this will be the program loaded. Okay. So just see, I only wrote one line of coding here. That is nothing but ADDS data 1, data 2, data 3. In turn, it was expanded into these three lines. One line was expanded into these three lines. This in turn was expanded into 9 lines. So this is the actual program. Okay, this is what is going to be loaded into the memory and executed. You understand? This particular concept is called macro call within a macro. So this is, which is macro call within a macro? This is a macro call within another macro. Okay, why is it different? Because we have only seen macros called from a main program. We have never seen macros called from another macro. So this is one situation, right? So again, it's an important concept. So in macros, you have to know what is macro call, what is macro definition, what is macro expansion. How do you have macros with arguments? What are the different types of arguments? So what do you mean by conditional macro? Right? So these are all 5 mark questions, all are important questions only. Right? And this topic is nothing but macro calls within a macro. Right? So there is one more topic which is going to talk about macro definitions inside a macro. Right? So let us see. It's like one macro defined, inside that I am defining another macro, inside that I am defining another macro, and so on. Okay? This was macro call inside a macro. Okay, how is it different from the next topic is, here I have the definition outside this macro. Okay, there what I will do, the macro definition itself will be inside one macro. So there will be one macro, inside that there will be another macro definition, and so on. So that is the next topic we are going to see. Yes. So before seeing what this inner macro is not defined until the outer macro, let me go to the example and then come back to the slide. Right. See here, there is a macro, right? There is a macro definition. Let us say it just says an example, define macro and name. Okay, some macro definition is there. So let us say outer macro. Let me name it as outer. Okay, let us say the macro name is outer. Inside outer, there is another macro keyword. Inside that there is another macro. Let us say the name is inner. Okay, so I'm going to just say name is inner and outer. Here the name is going to be inner. And let us say the name is going to be outer. Is it right? No. Okay, here the name is going to be outer, sorry. And this here the name is going to be inner. This is the inner macro, nothing but the inner macro. So there is a macro definition, the name of the macro is outer. Inside that there is another macro definition, the name of which is inner. So this inner macro has these three lines of code, and it is ended here. M and inner macro is ended. This M and outer macro is also ended. Okay. It is again kind of a nest, but one macro completely inside a macro. It is not a call, it is a definition itself. Okay. How can, is there a possibility for me to call only the inner macro? Can I call anywhere in the program? If I call only the inner macro, what happens? Okay. You will not be able to execute that inner macro alone. Only if you execute the outer macro. Why? Because the inner macro's definition itself is inside the outer macro. That's what this line means. Inner macro is not defined. Okay, inner macro, if you wanted to use the inner macro has to be defined. Yes, any function if you have to call, first of all it has to be defined. Yes or no? So outer macro will be defined in the beginning, right? Only when somebody calls the outer macro, the inner macro will be defined. Only then the inner macro can be used. Yes? So let me again repeat. So what are we trying to say here is, if I have to say there is a function definition, there is a macro definition. If I have to call the macro, first of all it has to be defined, right? So this inner macro will be defined only when the outer macro is called. Okay, the inner macro will be defined only when the outer macro will be called. Let us again see one example and I will try to explain this. See what is happening here is, in the main program will be there. Okay, let us consider this is the main program. Okay. In this main program, I have to call this outer macro. I have to call this outer macro with giving some arguments. I have to call the outer macro within giving some arguments. So what happens? That will be expanded into, so expansion will happen here. That will be expanded into what? This macro definition, right? It is going to be expanded with macro definition. First line is another inner macro definition, and then 3 lines of code is what will be the expansion. Second step, again I have to expand, right? I'll have to again expand here. How will that expansion be? It will have first this wherever this call was there, it will be expanded with these 3 lines of code. You understand? So that will be the final expansion. So that what you see there is going to be the final expansion. You understand? So the same like this. If you visualize it, it is going to be same like this slide, wherein you will have a macro first, a bigger macro, outer macro definition will be there. That macro definition has to be called here. Only then the inner macro definition itself will happen. You understand? Only then it can be defined, and then only you can call and use it somewhere in your program. So just a conceptual thing. Okay. So what is important in microprocessor chapter is you have to know about macro calls, expansion of macros, okay, macro definition. So these are the things you should know. Then also, as I told you, you have to know about arguments, and you also should know about conditional macros and macros definition inside a macro call inside a macro. So these things have been repeatedly asked. So I don't have to tell you, there are also 2 passes, macro pass 1 and macro pass 2. So again, it's up to you. You have the flow chart. You can write it in form of algorithm and study. That is another important question. So any one will be asked. Okay. Apart from that, the next class I have planned to discuss the data structures used in your pass 1 and pass 2 of the macro. Again, that is another important question which has been asked. So if not asked as a 5-mark question, usually it is asked as a 2 marks. AL, MNT and all is asked as a 2-mark question. So the next class we will discuss about what are the data structures. Okay. So what we have covered so far, we have finished the unit 1. Introduction unit is done. Unit 2 is done. This is going to be unit 3. So all the important questions of unit 3 I have done it. Yes. And then you have to also prepare yourself with pass 1 and pass 2 of the microprocessor. Right. In the next class we will discuss about the data structures which is used in pass 1 and pass 2. Thank you.